Hello, I'm Miss Igo. Welcome to my classroom. Today we're going to talk about linear inequalities. To begin, let's define inequality. An inequality is a mathematical statement containing the symbol greater than, less than, greater than or equal to, or less than or equal to. The difference between an equation and an inequality is the symbol that you see. X equals 5 is an equation. X is greater than 5 is an inequality. When we say x equals 5, what does this mean? This means that 5 is the solution to our equation, or x represents the number 5. When we say x is greater than or equal to 5, what does this mean? This means that 5 is a solution to our inequality, but also any number greater than 5 is a solution to our inequality. That means our solution could be 6 or 7 or 10 or 100 or a million, or it could be decimals such as 5.5 or 6 1/4 or 5 25/100. Any number that is 5 or greater would be a solution to our inequality. When we say x is greater than 5, what does this mean? This means that our solution is any number greater than 5, but 5 is not included. So our solution could be 5 1,000th, so it could be 5.001, or it could be 100 or a million or any number greater than 5, but again, it could be anything that's in between those whole numbers. It's not just a whole number. It could be any number in between those whole numbers, as long as it's greater than 5. And again, 5 is not included in that solution. Because of the fact that our inequalities include so many answers, an infinite number of answers, because again, as long as it's greater than 5, it's a solution, we use number lines to represent our solutions. To show that a number is part of a solution, we use a bracket on the number line. So if you have equals, less than or equal to, or greater than or equal to as your symbols, we use a bracket on the number line on that number. To show that a number is not part of a solution, we use a parentheses on the number line. So if you have less than or greater than for your symbols, use a parenthesis on the number line. Once we mark the number with either a bracket or a parenthesis, then we draw a line with an arrow at the end going either to the left or the right to show if our numbers are greater than that number, or if our solutions are greater than that number or less than that number. As long as your variable is first, so if you write your inequality with your variable first, if you have the symbol greater than or equal to, you're going to shade to the right. And if you have less than or equal to, you're going to shade to the left. If your variable is not first, then you would just go the opposite direction, or you can flip your inequality and then follow this rule. So now let's practice graphing solution sets for equations and inequalities. To graph the solution set for x equals 5, like we said, to show that a number is part of the solution, we would use a bracket on that number. Well, we don't usually graph an equation, so we could use a bracket like this or a bracket going in the other direction. But again, we usually don't graph the solution set to an equation. So we could even put a dot and say that, well, that is the only number that is part of our solution. This is an inequality. It says graph the solution set for x is greater than or equal to 5. So on the number 5, since this is got the equal to underneath it. So one way that I remember which symbol goes with which inequality, when we see greater than or equal to, or less than or equal to, these have these bars underneath our inequalities. That reminds me of the straight lines that are in the brackets. Whenever I have the inequalities just greater than or just less than, there are no bars underneath those symbols. So those we use parentheses. So in this example, because we have the bar under our inequality, or as part of our inequality symbol, on the number 5, we're going to use a bracket. And then since it's greater than or equal to, and since our variable is first, we're going to shade to the right. So let me show you how I remember that. To me, this inequality symbol looks like an arrow. So as long as our variable is first, we just follow the arrow to know which way to shade. So this looks like an arrow pointing to the right. Excuse me. So we're going to shade to the right. Whenever we have an inequality going to the left, if we have less than, then we're going to shade to the left. This says graph the solution set for x is greater than 5. This does not have a line underneath it. It's not greater than or equal to. It's just greater than. So on the number 5, we're going to use a parenthesis. And again, our variable is first, so we're going to follow the inequality symbol, and we're going to shade to the right. Make sure you put an arrow at the end of your line because that's representing that our line continues. It goes on to the right forever. Now we'll graph the solution set for x is less than 5. Because we don't see a line underneath our inequality symbol, we're going to use a parenthesis. And because our inequality symbol is less than, or it looks like it's pointing to the left, we know we're going to go to the left. So we're going to use a parenthesis. It's going to curve this direction because we know that we are going to be drawing our arrow to the left. And that's how we graph the solution set to x is less than 5. So the solution set for x is less than or equal to 5, again, we look to see if we have a line underneath our inequality symbol, and we do here, so we know we're going to be using a bracket on the number 5, and it's less than, it's going to the left. Also, this says less than, so that's just telling us it's all the numbers less than 5. So we use a bracket on the number 5, and we go to the left and draw an arrow at the end. To solve an inequality, we solve it just like we would an equation. Our goal is to isolate the variable, and because of the fact that we discussed the rule that if our variable is first, we know which direction to shade. Let's try getting our variable by itself on the left side of the inequality. If we don't, we can simply flip the whole solution. That means we would have to flip the inequality symbol also, and then we would have our variable first. But let's start with the goal of having our variable on the left side of the inequality symbol. So to isolate our variable here, we want to get the x by itself. That's what I mean by isolating our variable. And so the first term that we would move would be the 4. So just like we would in an equation, to move the 4 from the left side to the right side of the inequality symbol, I'm going to do the opposite operation, which would be to subtract. So I have 5x is less than, and that would be negative 5. Now, to get the 5 off of the x, the 5 and the x are being multiplied, so the opposite operation would be to divide. So we get x is less than, I'm going to reduce my fraction, and I get negative 1. And now we would graph our solution just like we were graphing our numbers earlier. Our symbol is less than, not less than or equal to, so we're going to use a parenthesis on negative 1. And then it's less than, or it's pointing to the left, so we're going to draw our inequality to the left and put an arrow at the end. We can also represent our solution in interval form. So an interval is where our solution begins and where it ends. And we always write our interval from left to right. So if we look at the number line and we look at our solution, we see that there's an arrow pointing to the left. So if I start at the left and my arrow is going towards the left, that means that my solutions start at negative infinity. And if we go from the left to the right, it's going to go to the right until it gets to negative 1, and it stops at negative 1. Now, we have to enclose our interval. For the number part, that's easy. We're just going to use the same symbol that we used on the number line where that number is. For the infinity part, just know that our enclosures for our interval tells us whether or not that number is included. Well, we said that negative 1 is not included. That's why we use a parenthesis. Infinity is not a number that can be included because it goes on forever. So our infinity symbols, whether it's negative infinity or positive infinity, is always going to be parentheses. Now we can have interval forms of our solutions with different ends. So we could have a parenthesis on one end and a bracket on the other end. Or of course, just like this, we can have the same parentheses or brackets on both ends. But they won't always be the same. So we have to pay attention to each end of our interval. All right, here's another inequality. Let's solve this inequality. Again, I'm going to go for getting my x's on the left-hand side of the inequality. So I'm going to add 2x to both sides of the inequality. That gives me 3x plus 1 is greater than or equal to 3. Now I want to isolate my x, so I'm going to start with what's farthest away or undo addition and subtraction first. So I'm going to undo this plus 1 by subtracting 1 from both sides. And that gives me 3x is greater than or equal to 2. Then, just like before, my last step is to divide. I'm going to divide both sides by 3. And I get that x is greater than or equal to 2/3. Okay, so my solution is not a whole number, but I can estimate approximately where 2/3 would be on the number line. I know that 2/3 would be between 0 and 1. 2/3 is not quite one whole, so it's between 0 and 1, a little bit more than a half. So right in here is where 2/3 would be. So on 2/3, am I going to use a parenthesis or a bracket? Well, because I have this equal to, or this line underneath my inequality symbol, I'm going to use a bracket. So let me put a bracket approximately where 2/3 is on the number line. And then since my variable is first, I'm going to follow the direction that my inequality is pointing, and I'm going to shade or draw my line to the right and put an arrow at the end. Again, we're going to write our solution in interval form. And so, as I said before, we're always going to write our intervals from left to right. So we look at our graph, and where does our graph start? This graph starts at 2/3. And again, I said use the sign that's on our number line where that number is. So we're going to use a bracket. It starts at 2/3. And then as we go to the right, where does our graph go? It goes to positive infinity. And as I said before, the infinity symbols, whether it's negative infinity or positive infinity, we're always going to enclose those using parentheses. When solving an inequality, it's very important that you are aware of this rule. If you're solving an inequality and you multiply or divide both sides of the inequality by a negative number, you must reverse the inequality symbol. Let's solve this inequality. We have negative 4x is greater than x. So to solve this inequality, we would divide both sides of the inequality by negative 4. This gives me x on the left side, and on the right side I would have negative 2. But we need to make sure that because we divided both sides of the inequality by a negative number, we have to reverse the inequality symbol. So instead of saying greater than, it now should say less than. Now we're going to graph our solution on the number line. So on negative 2, are we going to use a bracket or a parenthesis? Because we don't see the equal to line underneath it, we're going to use a parenthesis. And we're going to follow our inequality. X is less than negative 2, so we're going to draw our line towards all the numbers that are less than negative 2. Our interval, we're going to start at the left. Where does it start? It starts at negative infinity, and because it's an infinity, we use a parenthesis. And we go to the right until we get to negative 2, and we use the symbol that's on that number, which is a parenthesis. This inequality says negative 3/4 x is greater than or equal to 30. Well, the negative 3/4 and the x are being multiplied. So to undo that, or to get rid of the negative 3/4, since that's being multiplied, we would need to divide, but we can't divide a fraction by a fraction. We have to multiply by its reciprocal. So to solve this, we're going to multiply both sides of the inequality by the reciprocal of negative 3/4. The reciprocal of negative 3/4 would be negative 4/3, or 4/3. And whatever we do to one side of the equation, we have to do to the other side of the equation. Now, when I multiply a number of times its reciprocal, it just turns into a 1. So that's 1x is, since I am multiplying both sides by a negative number, I have to reverse this inequality symbol, and it's not going to say greater than or equal to. It's now going to say less than or equal to. Okay, so for the other side, I'm going to go ahead and reduce this fraction. 3 will divide into 30 10 times. So now I have 10 times negative 4, so that would be a negative 40. So my number line doesn't have the numbers on it because they were so big. So if I'm going to draw my number line, I'm going to just put negative 40 right here and put numbers that are close to negative 40. So we know that this would be negative 39, negative 38. This is negative 41, negative 42. Okay, so you get the idea. Okay, so on negative 40, we would use a bracket because we have that straight line there. And then we're going to follow our inequality symbol. So we're going to draw our inequality line, our number line to the left, or shade our number line to the left. So now let's write our interval form of our solution. When we start at the left, we're starting at negative infinity. We enclose that with a parenthesis, and it goes to negative 40, and we're going to close that with a bracket. All right, here we have a little more complicated inequality. Again, we solve inequalities just like we would solve an equation. We just have to remember that rule about multiplying and dividing by negative numbers. When we do that, we flip the inequality symbol. But here we have a set of parentheses, so just like in an equation, we would need to get rid of those parentheses first by using the distributive property. So I'm going to distribute this negative 2 into the parentheses. When I do that, I get x, and that would be negative 2x or minus 2x, and then negative 2 times negative 4 would be a positive 8, is less than or equal to 3x. Next, I would combine my like terms, x and negative 2x, that would be a negative x plus 8 is less than or equal to 3x. Okay, I want to get my x's together, so I'm going to add x to both sides of the inequality, and that gives me 8 is less than or equal to, that would be 4x, and then I'm going to divide both sides by 4. So that gives me 2 is less than or equal to x. So here's an example where I got my solution, but my variable is not first. So I can simply flip my inequality. So this would be the same as if I flipped everything and I got x. I would have to flip the inequality is greater than or equal to 2. Now I'm going to graph my inequality. So on the number 2, I would use a bracket because I have that line. All right. And I'm going to go to the right. Now, let me just explain this. So this says 2 is less than or equal to x, or x is all the other numbers. Okay, so 2 is less than or equal to all the other numbers. Well, here's all the numbers. 2 is less than that. This inequality says x, or all of the numbers, is greater than or equal to 2. Okay, so here's 2. All of the numbers greater than or equal to 2 are on this side. So these two statements are the same. They're equal. Now let's write the interval form of the solution. All right, so we start with the left. So the part of the solution that is all the way to the left is our number 2. And we're going to enclose it with the same symbol that's on the number line, which is a bracket. We have the number 2, and then it goes to the right forever, so it goes to infinity, and we close that with a parenthesis. Okay, this is our last example. We have 8 times 1/2 x plus 3 is less than 8 times 1/2 x minus 1. As we do with any equation or inequality, if we have parentheses, we want to get rid of those first by distributing. So I'm going to distribute the 8. When I multiply 8 times 1/2, 8 times 1/2, that's like 8 over 1, so that would give me 8 over 2, which is 4. But anytime I multiply a whole number times 1/2, I can think of it as taking half of the number. So half of 8 is 4. And then 8 times 3 would be 24. Okay, again, I'm multiplying 8 times 1/2. So I'm taking half of 8, which is 4. And then 8 times 1 would be 8. All right, I want to get my x's together, so I'm going to subtract 4x from both sides. And that causes both of my variables, or my variables on both sides, to cancel out. And I'm left with 24 is less than negative 8. Well, when we get a statement like this where our variables go away, Look at this statement and see if this statement is true. This says that 24 is less than negative 8. Is that a true statement? Since that is not a true statement, we say that we have no solution. We would not put anything on our number line for our graph because there's nothing to graph. And for our interval, we would write this. We would say that there's no solution, a 0 with a slash through it. The solution set is the empty set. There is no solution. Let's say, for example, we got something that was true. Say if we had 24 is greater than negative 8. Well, that would be a true statement. If we had gotten this for our solution, then on our number line, we would have arrows going in both directions, and we would have a number line that just went with arrows in both directions. And our interval for something that looked like this would be from negative infinity to positive infinity. So these solutions, these types of solutions are rare, but when it happens, when our variables cancel out, we don't have just x is less than something or x is greater than something, then we can either have no solution or all real numbers would be our solution. And again, we look to see if our statement is true or false. If it's false, then we have no solution. We don't put anything on the graph. If it's true, then it would be all real numbers. So we graph the whole number line and put our interval as negative to positive infinity. And that's how we solve inequalities.